Hi everyone, so we're doing Unit 4, Lesson 1. Unit 4 is on congruence, and this is the introduction to congruence. The first definition is congruent polygons have congruent corresponding parts. They're matching sides and angles. Matching vertices are corresponding vertices. When you name congruent polygons, always list corresponding vertices in the same order. So when you look here, if you look at the diagram, the way that they're marked, see how this has the one angle mark. So angle A is congruent to angle D. This has the two tick marks here. So that angle B is congruent to angle E, and C is congruent to F, and then the sides are labeled too with the tick marks. So you could say that side AB is congruent to side DE. And then you can also say BC, side BC is congruent to side EF, and side AC is congruent to side DF. And then it would be the same. Polygon PQRS is congruent to polygon WXYZ. So the way that it's written is important. That tells you the angles, same as in the triangle up here. A is congruent to D, B is congruent to E, and C is congruent to F. It works the same here. Angle P is congruent to angle W because they're both first. Angle Q would be congruent to angle X because they're second. Angle R is congruent to angle Y, and angle S is congruent to angle Z. And then you do the same with the sides. Side PQ is congruent to WX, so on and so forth. So down here, example 1 says, given that triangle ABC is congruent to triangle LMN, list the congruent corresponding parts. So right away, from the way that it's written, we can say we know that angle A is congruent. That would be angle A is congruent to angle N. Then we'll go to the second one. Angle B is congruent to angle N. Then angle C is congruent to angle N. Then we'll label that too. So we'll go angle A, a little wider. Angle A is congruent to angle L. So you use 1 the first time, then I'm going to use 2 for angle B. Angle M, and then 3 for C, 3 for N. So we know this is congruent. And then from there we can do the side. So we can say side AB is congruent to side LM. Then we can say side BC is congruent to, so B is second and C is last. So over here, it's going to be MN congruent to MN. And then we have the last one would be AC. So it's first and last, and then we go first and last. It's congruent to side LN. So when we do that, we have AB. It's 1 tick mark. LM gets 1 tick mark. So those are congruent. BC gets 2 tick marks. MN would get 2 tick marks. And then AC get 3, and LN would get 3. So we know that that side's congruent to that side by looking at that, the way we labeled it. So what's really important is to the order. They have to be written in order. So angle A is congruent to angle L, and then when you do the sides, it's the same. AB is congruent to LM, BC to MN, AC to LN. Okay. Example 2. Can you conclude that triangle ABC is congruent to EDC? Justify your answer. So when you're looking at it, we can say that we know that the sides are, we have all the sides, so we have side CE is congruent to side AC. We have side ED is congruent to AB. And then we have side CD is congruent to side BC. So all of those are true. We can tell by the way it's marked. Then we have angle A is congruent to angle E. Then we can prove that angle B and angle D are congruent. They're both right angles. And then the last angle is angle C here in both triangles. So you can mark that because these we know are vertical angles which are congruent. So we can say because they have the same letter, we have to use all three letters. So you're going to say angle ECD is congruent to angle ACB because of the vertical angle theorem. So then the answer is yes. You can conclude that triangle ABC is congruent to triangle EDC. And this was the right angle theorem. Now let's see if it works for example 3. So can we conclude that JKL is congruent to NML? So in order for that to be true, angle J would have to be congruent to angle N. So angle J and angle M. That's not what's marked here. This only has one mark that says 2. So they're not congruent. So that's not going to work. And even if we went further, we do have the vertical angles here, but that's only one of the angles. Angle K and angle M, they're also not congruent. So here we're going to have to say, no, you cannot conclude that triangle JKL is congruent to triangle NML because you don't know that the corresponding parts are congruent. So the answer is no for that one. So for the third angle theorem, it says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So if you know that angle C and angle K are congruent, and you know that angle B and angle J are congruent, then you can conclude that angle A is congruent to angle L. That's what that's saying. Example 4. Write a statement that indicates the two triangles below are congruent. So again, it matters what order you write them in. So angle T is congruent to J, so they're going to have to be the first letters in the triangle. So triangle J and triangle T. Then we'll look for R. Angle R is congruent to K. So we'll put K and R. And then finally you have I here, and you have S here. JKI, it's congruent to triangle TRS. And you have to write them in that order. So they're in the corresponding sides, though. I'm saying you have to write it in that order, but you could potentially say triangle KIJ is congruent to triangle RST, as long as they're in the same spot. Okay, so example 5, write a statement that indicates the two triangles below are congruent. So again, we have triangles is congruent to triangle. So the first one, so here we'll have P, so we have Q and we have P. So Q and P. Then we have P and then Q. And then finally we have R and we have D. So you have triangle QPD is congruent to triangle PQR. Example 6. Find the values of X and Y in the diagram below. So first, if we're going to do X, this 2X plus 6 is referring to this side. So this side is equal to this side. So we know that 2X plus 6 equals 20. Subtract the 6, 2X equals 14, divided by 2, X equals 7. And then for the Y, it's referring to this, 2Y plus 13 is this side, 4Y minus 9 is this side, so they should equal each other. So you have 4Y minus 9 equals 2Y plus 13. I'm going to subtract the 2Y. So we have 2Y minus 9 equals 13. Add the 9. 2Y equals 21. Divide by 2. Divide by 2. Y equals 11. The light just turned off in this room, but that's okay. You can still see. So on the last example, example 7, it says in the diagram below, quadrilateral ABDC is congruent to quadrilateral QSRT. Find the values of X and Y. So right here to do the Y, we have our side RT. So when you look here, it's RT is here, so it's going to be congruent to DC. So this side here is congruent to this side here. So we know that side RT is congruent to side DC. So then we can plug in the values. 4Y minus 3 equals 25 plus 3 plus 3 is going to be 4Y equals 28 divided by 4 divided by 4, Y equals 7. Now when you're doing the next one, you're looking at side RS. So side RS is going to be congruent to DB. So DB is down here. So we have, I just crossed it out. All right, so 3X plus 5 equals 14. Minus 5, minus 5, 3x x equals 9, divide by 3, x equals 3. And that is the first lesson of Unit 4. Have a good day.